Hi, everyone. Welcome to this conversation on cloud in a Web 3.0 world. My name is Adeel Omer. I'm a VP of Marketing at Lumen Technologies. And I'm here because this is a topic that's really near and dear to my heart. I started off my career as a developer in the Web 1.0 era. And those times were so dramatically different. We thought we were changing the world then. But with Web 3.0 and this new era of distributed technologies, we're in a place that's unlike anything we've seen before. And I'm so glad to be a part of it, although not as a developer, more in terms of the backend technologies that enable Web 3.0 and distributed applications today. So let's go ahead and get started about Web 3.0. So a little bit of a brief history lesson. So dating myself, but I started my career back in the Web 1.0 days. This was the Netscape Navigator days, AOL. You used to have to dial up. But the characteristics of Web 1.0 were it's mostly a one-way feed of data. You went onto the web to consume information. There were publishers, content publishers, the CNNs, the Yahoos of the world. And then you would be the consumer. And so this is all, pages made in static HTML, mostly one directional, as I said. Web 2.0, we started to see in the early 2000s, is when content became more and more derived from users. And so today, that's kind of what the world is that we live in that's been popularized. So Facebook, Meta, Instagram, Twitter, Reddit, those are all, communities where users like yourselves and myself contribute data and enrich the platform. So data is a lot more two-way. Of course, people have also found ways to monetize data, and that is such a key theme of what enables organizations to make money today. Again, characteristically, dynamic content, but user-generated content. And now we're starting to enter this world where it's not just the data from those applications, but it's the increased utilization and production of that data by not just humans, but by machines. And of course, being able to do it at a scale that is just unimaginable, where machines are analyzing data, analyzing behaviors, creating dynamic experiences that weren't programmed by a human. That's what Web 3.0 is trying to capitalize on. In addition to that, there's some other characteristics as well. So if you think about, the transition to Web 3.0 apps, the key shifts that will start to happen or are possibly already happening. The first one, I think the most important one is instead of this organizational control over your data, over the way things are organized and set up, the contracts, that goes from an organization being in charge to individual control. So a great example of that is cryptocurrencies. Right? You don't need to have a central bank or an authority kind of legitimizing a transaction between two parties. It's party to party directly. And the record happens to be publicly available. You've got content technologies that were previously human programmed, right? Now going towards more AI and smart contracts that change behaviors between the two parties that agreed to the contract based on the terms of that contract. You've got trust instead of it being in an authority like a Visa or a MasterCard. There's an open standard. It's out in the public for everybody to see and to observe. The flip side of that is, you've got a lot of data that is trustless and does not require anyone's permission. So there is no publication standard. Everything's kind of out in the open, which can be a really big source of freedom in many ways. And then finally, and I think this is the single thread between the Web 2.0 to the Web 3.0 transition is instead of centralized everything, we're now moving to distributed everything. And I'll talk a little bit more about that. But essentially think about every part of what it takes to take a web application to you goes from being in a central place that is super powerful and omnipotent and has control and visibility into everything to those same levels of control and that application and that code and that data and all that knowledge being distributed across this living body that Web 3.0 just basically enables. Okay, so let's take an example of how applications and data work today in the Web 2.0 world moving into the Web 3.0 world. You have billions of devices, right? Your offices, in your homes, your smart car, your cell phones, they all transmit data, wired or wirelessly, through a global network, a massive global network. And all that data makes its way to the public cloud, right? The Googles, the Amazons, the AWSs of the world, where that data is operated upon, and then you get a response, right? Now, when you get, tens of billions of devices, and those are growing, and you have more people, and you have experiences that are even more data intensive, it just isn't efficient for all that data to travel 2 states across or travel to a different part of the world. So how do you do this more efficiently, more securely? How do you allow for people's data to remain private when so much of this data is just traveling from one end to the other? The other part is a lot of that data doesn't need to live beyond the point that it's created. If I have a security camera that's looking at a closed door, I don't really care as long as that door isn't opened. So that's an event. That processing needs to happen at a different place versus some massive machine learning algorithm that needs to run in the public cloud. So where we're going now is towards a world where you have more and more edge computing locations. So the data is transferred to the nearest possible place where it makes sense for that data to be acted upon. That might mean on premises, right, where the data is being produced. So in my factory floor, in my office floor, on the car that I am driving, that would be sort of like your gateway solution, right? Or it might be a block down in a metro edge location where you've got edge servers that are providing the fastest possible performance for your unified communications and video conferencing tools, because lag on video conferencing kind of sucks, right? It could mean virtualized servers and virtualized storage services. It could require some orchestration of where my applications are going to live. So there's this paradigm shift. And what you've noticed here is a lot of those things that previously would just be either on my 4th floor office lab or would be out in the public cloud now get distributed seamlessly. There is no boundary. There is no perimeter of where I am and my devices are and where the public cloud lives. So now what we're starting to see is a lot of businesses are investing in this edge infrastructure. In fact, more than half of the IoT workloads that are going to be executed this year are going to live near edge or on the edge, right, on the premises, which is a huge number, right? It shows you that the world is moving closer and closer to that point of digital interaction. And the primary motivations for doing this are, hey, bandwidth is expensive, right? It's cost prohibitive. I get better security. I get better control over my data. I get better visibility into my data. The latency requirements that I have for the performance of my applications are very important to me. So I want that compute power to be as close to me as possible. Then there's greater reliability consequences with edge computing. You get better redundancy. Those are all the benefits of why organizations are moving towards, remember I said, centralized to distributed. So distributed is increasingly becoming more and more popular. Now, one of the things that we are starting to see is this shift in architecture that I just kind of touched on at a high level. You had an evolution of the natural client-server model, now moving back to this distributed compute model. And even though we're saying that now compute services can live anywhere, your applications might even be broken down to live in different places. So if I am out for a run, there's a part of the Spotify app that lives on my watch. There's a part of the Spotify app that lives in the cloud. So applications not only talk with one another, but there might be a GPS service, right? And that software runs on my watch. There are other applications that are running on my watch. That's device specific, but they might be communicating with something that is a local service. So my weather service might be something that needs to live on an edge compute location because centralizing it might not be beneficial for such a hyper local service. We see all this preponderance of applications. Underneath it all, though, we see that applications are ultimately still going to run on platforms which run on infrastructure. So what is your infrastructure? It's the fiber networks that connect global data centers. It's the servers. It's the physical hardware. That physical hardware then has a bunch of technology services. And this is what I'm most excited about, which is the platform, this concept of taking all of this hardware and providing it as virtualized services that you and I ultimately rely on. So even though I'm just relying on the Spotify app on my watch, ultimately it's running a data transfer protocol session. It's running authentication for my credentials. It's transferring data from a server in the cloud to my local telco over a network wirelessly to my watch. Those are all services that we are all going to start to rely on. And they happen because there's this platform to run applications that continuously helps us transfer that data that we need. So I live in my world at the application layer, right? That's how I interface with the technology stack. All the way down, you've got the physical stuff, but in the middle, it's the real meat of it all. And all of us are contending with a world like the IT practitioners, all those of us who work in the technology sector are working with this changing world where the platform is going to become the most important thing. And it doesn't matter if you're a developer, it doesn't matter if you work in IT, it doesn't matter if you are in operations, it's becoming one big ball of wax, right? It includes the virtualized IT services, it includes finding the right cloud environment for your applications, and it ultimately includes having the right kind of orchestration so the right application can live in the right place. Now, what do we mean by the various layers of the platform? So we talked about, I've got the physical data center, I've got the application on the top. There's a bunch of stuff in the middle, right? There's the virtualized services for compute. There are routing policies. There are security policies. There's load balancing. There's application security. There's an application hosting environment that might take your VM or it might take your container and host it all. Those are all parts of a platform that enables a distributed computing environment. So as you develop Web 3.0 applications, you develop applications that rely on constant connectivity. It's important to consider all these architectural considerations and their dependency on an underlying network, because we like to forget that there's all this complexity. And hey, I'm just a developer. Here's my Dockerized application, and it has all the requirements just deployed in the best possible way for me. But that's easier said than done. And as a developer, it's important to know what the underlying levers are that you can pull to improve the performance, to improve the resiliency, to improve the security of your applications. And that's a concern that you might not have to worry about most days, but knowledge about those considerations helps you become a better developer as well. The other thing about Edge that's super exciting is you still get the same platforms that you've always been used to. So if you want Node.js hosting, you want caching capabilities, you want DNS hosting, you want SSL, those are all services that run as platform services. But now in your mind, you know that those services are running closer to the point of digital interaction, and that'll get me better performance. That can be part of your application design considerations. So really important to start to think about the underlying infrastructure that enables your platform services. And then finally, as I said, this is always top of mind for every IT professional that I've ever talked to, and that is security. When my data constantly moves from my device to the cloud to 100,000 ad platforms, how do I make sure that the right encryption is being applied? How do I make sure that if I have a e-commerce website, that it's not under attack? How do I make sure that I am keeping malware away from all the devices that I'm trying to protect? So there's considerations around the selection of a platform for Edge that should lead you towards saying, what is your built-in security? How do you treat layer 3 and layer 4 security? How do you treat application level security? How do you have WAFs and WAPs to protect where my applications live? And those are all really critical considerations for a platform that's going to host applications. And again, when those applications are distributed, they're all still connected by the network. So if you are exposed in one place, you're going to be exposed in a lot more places if you're not protecting your applications by design. And so it's really important for the platform to provide that as a capability. And then finally, as I said, performance, latency, those are all really important considerations, but you have to define them. And the platform needs to be able to understand those definitions and those requirements. So when we think about application performance, application latency, load balancing, when we think about the ability to provide that end user with the best possible experience, one of the most important things that we focus on is, do we have the visibility into what that performance is in every part of the network? So for instance, if I'm a large media and content provider, and we just released the last season of a super popular show, now that content needs to be distributed to users worldwide in the most efficient and most, technologically advanced way, so that everybody at the end doesn't experience buffering. And organizations that are trying to deploy that code and that content in the best possible way have visibility into what the performance is. So visibility into that security, visibility into that performance is super important. So we at Lumen have been designing our Lumen platform specifically with those needs in mind. How is it performing? Do you have visibility into that performance? Is it secure? Is it connected with greater redundancy that you might need in case something goes down? Do you have the ability to expand and scale up that capability? Do you have the ability to spin up and spin down those services as necessary and as demand fluctuates throughout the day? Those are all things that we naturally found ourselves in a very enviable position to be able to deliver. The Lumen network connects to more public cloud servers, public cloud locations than any other network in the world. We own a lot of our own network. So you think about the application, you think about the platform, you think about the infrastructure. We own a lot of that infrastructure, which allows us to have the visibility and those integrations that allow us to deliver those kinds of dashboards for security, for performance that would otherwise not be possible. So really proud of how our platform strategy for Edge, for Web 3.0 applications, really gives us a little bit of an edge, no pun intended. As you can see here, owning one of the world's largest network gives us this distinct advantage. We've been investing in edge node locations. We're very proud that because of those, the 4 laws that enable how quickly data can transfer from one place to another, our network allows us to deliver sub 5 millisecond latency to over 97% of enterprises in the US. It's over 70% of enterprises in Europe. It's because we are turning our network into the data center, in effect, by taking all of these server locations and putting them as edge compute locations within our network. That coupled with the interconnectedness, that coupled with our digital experiences for you to go out and deploy your bare metal servers with the orchestration on top, really gives us a bit of a distinct advantage. So in summation, whether you're a developer, whether you're an operations professional, whether you're an IT professional, when you start to think about edge, you start to think about deploying your applications on the edge, think about those 3 things that I talked about. Think about the underlying infrastructure, think about the platform and the capabilities of that platform, and then finally, think about the needs of your application and whether the underlying platform and the infrastructure have been designed to meet the needs of that platform. That is going to help you succeed in a Web 3.0 world. Thank you very much.